So today we are going to talk about the collisions. Okay, so let's suppose there is this body, its mass is m1. There is this another body whose mass is m2, and initially they are moving with some velocities. Okay, so let's consider a simple case first, that is the one-dimensional case, and then we'll move on to the two-dimensional case. Okay, so let's suppose they are moving in one dimension. Okay, so the speed of m1 is u1, the speed of m2 is u2. So we can consider these are two masses, okay, two balls or anything. So they are moving in a direction. So when will they collide? So m1 is ahead of m2. When will they collide? What is the condition that they will collide with each other? u2 must be greater than u1, right? Okay, the velocity of the object which is following must be more. Okay, then only it will be able to reach the first object. Okay, so u2 must be greater than u1, and then they collide. Okay, of course the color will not change, so they collide here. So they exert forces onto each other and then they separate. Okay, so now first one moves with a velocity of v1. Okay, m1 moves with velocity of v1 and m2 moves with velocity of v2. Okay, so now if they are moving in same direction, what will happen? The velocity of first one will increase, that is velocity of m1 will increase, because m2 is pushing it in the same direction as that of movement. Okay, and what will happen to the velocity of m2? It will decrease, because force on m2, okay, force on m2 due to m1 will be in opposite direction. Okay, so this m2 was moving in this direction. There is a force on m2 due to m1, it is in opposite direction, so its velocity will decrease, right? So velocity of m1 will increase, velocity of m2 will decrease. What else can you say about the collision? So they will follow law of conservation of momentum, right? They will follow law of conservation of momentum. Okay, so total momentum before the collision is equal to total momentum after the collision, right? So what is total momentum before collision? m1 u1 is momentum of first object, plus m2 u2 is momentum of second object, first ball and second ball we can say. It will be equal to what? m1 v1 plus m2 v2. So momentum before collision is equal to momentum after the collision. Okay, so they will follow law of conservation of momentum. So this is in one dimension. If we want to discuss three-dimensional case, what will be that? So m1 u1 bar plus m2 u2 bar is equal to m1 v1 bar plus m2 v2 bar, right? So we have to do nothing, we just have to put what? Vectors on top of velocities, that's it. So total momentum is conserved, right? Then we can define a quantity which is known as the coefficient of restitution. Okay, for collision there is a quantity known as coefficient of restitution. Restitution. Okay, so what is this coefficient of restitution? It is denoted by letter E. So this E is equal to relative velocity of separation divided by relative velocity of approach. Relative velocity of approach. Okay, so what will be velocity of separation? So see, what is velocity of approach? So you can say that u2 is more than u1, then only they will collide, right? These two bodies will collide if and only if u2 is greater than u1. Okay, so what is the velocity with which the second body is approaching closer to the first body? That is known as velocity of approach. So if first body was at rest, we could say it is approaching with velocity u2, but first body is also moving with some velocity. Okay, so the second body is coming closer with velocity u2, but first body is going away with velocity u1. So what is relative velocity of approach? It is u2 minus u1, right? It is u2 minus u1. And what is velocity of separation? So after collision, what will happen? The first body will move away, right? It will move away with velocity v1. Second body is also following with velocity v2. Okay, so first body is getting separated. So at when they collide, okay, when they collide, they are together, right? And just after the collision, first body gets separated from the second body. Okay, so what is velocity of separation? The velocity of first body minus velocity of second body, v1 minus v2. Okay, so the coefficient of restitution is v1 minus v2 divided by u2 minus u1. Okay, and if we want to consider the three-dimensional case, we just have to put arrows on top of this. So this is 3D case, and what will be 1D case? It is v1 minus v2 divided by u2 minus u1. This is one-dimensional case. Okay, so is it clear? This is simple, right? All right, so then the collision can be divided into some categories. Okay, so let's consider collision in one dimension. So one is the elastic collision. It is known as perfectly elastic collision. Perfectly elastic collision. Then second one is perfectly inelastic collision. Perfectly inelastic collision, and in between these two there is inelastic collision. Inelastic collision. Okay, so what happens in case of these three? Okay, let's see. So what is perfectly elastic collision? So in perfectly elastic collision, the momentum is conserved as well as the kinetic energy is conserved. Okay, so what is conserved? So first thing, momentum, total momentum is conserved. So total momentum is conserved. That means total momentum before the collision is equal to total momentum after the collision in case of perfectly elastic collision. So same thing happens for inelastic collision also. The total momentum gets conserved. Okay, so law of conservation of momentum is applicable everywhere. In case of any collision, it is applicable. So total momentum before collision is equal to total momentum after the collision. This is always true. Okay, so this thing is always true. So total momentum is conserved. So momentum is conserved, and in perfectly inelastic also momentum, that is total momentum, is conserved. Sorry. Okay, then second. So second is the kinetic energy. So in case of perfectly elastic collision, the kinetic energy also gets conserved. Okay, kinetic energy, so total kinetic energy of two bodies is also conserved. Okay, but in case of inelastic collision, the kinetic energy does not get conserved. So Ke is not conserved. Okay, kinetic energy is not conserved. Okay, so what's difference between inelastic and partially inelastic and perfectly inelastic collision? So we have seen what is conserved. Momentum is conserved everywhere. Okay, kinetic energy gets conserved in perfectly elastic collision. It does not get conserved in inelastic collision. Okay, partial inelastic or perfectly inelastic collision. So what is perfectly inelastic collision? So two bodies, two colliding bodies, they stick together and move together. It is known as the perfectly inelastic collision. So there is maximum loss of kinetic energy. Okay, so two bodies stick together and move together. Okay, so in case of, so this is second point. Third point, so what happens in case of perfectly inelastic collision? So two bodies, two colliding bodies stick and move together. Okay, so this thing happens only in the case of perfectly inelastic collision. Okay, and then we learnt about this coefficient of restitution. Okay, the coefficient of restitution. So if bodies stick together, what will be velocity of separation? It will be zero, right? Okay, if bodies stick together and move after the collision, stick together and move together. Okay, then what will be velocity of separation? It will be zero. So E is equal to what? Zero in case of perfectly inelastic collision. E is equal to zero. Okay, so and in case of the elastic collision, we will prove this. Perfectly elastic collision, E is equal to 1. E is equal to 1. What? E is equal to 1. Okay, so this is in case of perfectly elastic collision. So for inelastic collision, the E, okay, E is equal to, E is in between 0 and 1. Okay, so E is in between 0 and 1 in case of inelastic collision. So is the difference between elastic, inelastic and perfectly inelastic collision clear? So let's consider perfectly elastic collision. So what happens in case of perfectly elastic collision? The momentum gets conserved and also the kinetic energy gets conserved. Okay, so let's suppose we have these two bodies. We have these two bodies. First one is moving with velocity u1. The initial velocity of first one is u1. Mass of first one is m1. Initial velocity of second one is u2. Mass of the second one is m2. So they collide, and then what happens? The initial velocity, sorry, the final velocity of first one becomes v1. Okay, and final velocity of second one becomes v2. So we can write down some equations here. What can we write down? That since the momentum gets conserved, since the total momentum is conserved, total momentum is conserved, what can we say? That m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. Okay, total momentum before the collision is equal to total momentum after the collision. Okay, after that what we'll do, we'll take this m1 v1 on left hand side and m2 u2 on right hand side. So terms containing m1 on the left hand side, terms containing m2 on the right hand side. Okay, so this is the trick. Okay, so m1 u1 minus m1 v1, m2 v2 minus m2 u2. Okay, so what we want to do is we know the masses m1 and m2. We know the initial velocities u1 and u2, and we want to find out the final velocities of these masses, okay, v1 and v2. Okay, so what do we know? We know m1 and m2, u1 and u2, and we are interested in finding out v1 and v2, the final velocities, the expressions for final velocities in terms of m1, m2, u1, u2. Okay, and we know two conditions: the total momentum gets conserved and total kinetic energy gets conserved. So using those relations, the total momentum is conserved and total kinetic energy is conserved, we'll find out the relations for v1 and v2. Okay, all right, so this is a trick. Okay, this is a trick. Okay, then you can take m1 common, so you get u1 minus v1 is equal to, here you can take m2 common, v2 minus u2, and let's call this equation number 1. After that, so this is from conservation of momentum. Then we know that the total kinetic energy is also conserved. Okay, so total kinetic energy is also conserved. So what can we say? So half of m1 u1 square, this is kinetic energy of first mass, half of m1 u1 square plus half of m2 u2 square is equal to what? So this is total kinetic energy before collision. It is equal to total kinetic energy after the collision. So it is half of m1 v1 square, which is kinetic energy of first mass after collision, plus half of m2 v2 square. Okay, after that again we'll do the same thing. So this half gets cancelled. Okay, and then we'll move this m1 v1 square towards left, m2 u2 square towards right. So terms containing m1 towards left, terms containing m2 towards right. Okay, so m1 u1 square minus m1 v1 square is equal to m2 v2 square minus m2 u2 square. Okay, and then again we'll take m1 common, so I get u1 square minus v1 square, and this is equal to m2 common, so here v2 square minus u2 square. Okay, then what can we write? So a square minus b square, we know it is a minus b multiplied by a plus b. Okay, so we have m1 multiplied by u1 plus v1, here u1 minus v1. Okay, u1 plus v1 multiplied by u1 minus v1, it's equal to m2 multiplied by v2 plus u2 and multiplied by v2 minus u2. Okay, and then you can check this equation number 1. So we have m1 multiplied by u1 minus v1 equals to m2 multiplied by v2 minus u2. Okay, so m1 multiplied by u1 minus v1 is m2 multiplied by v2 minus u2. So this thing gets cancelled out. Okay, this thing gets cancelled out. So what do we get? We get u1 plus v1 is equal to v2 plus u2. And from this, what can we say? That so v1 minus v2. Okay, I will take this v2 towards left. Okay, and u1 towards right. So V1 minus V2 is equal to U2 minus U1. Okay. So I will mark this equation. This is my equation, or let's wait. Okay. So V1 minus V2 is equal to U2 minus U1. Right? Then I can divide this by U2 minus U1. So what do I get? If I divide, I get V1 minus V2 divided by U2 minus U1 is equal to 1. And what is this? This is coefficient of restitution, right? Okay. So we have proved that coefficient of restitution is equal to 1 in case of perfectly elastic collision. So is it clear till this point? Okay. So coefficient of restitution is equal to 1 in case of perfectly elastic collision. Alright. So then we have this thing. U1 plus V1 is equal to V2 plus U2. Okay. So U1 plus V1 is equal to V2 plus U2. And from this, what we can do is we can take V1 or V2 and substitute for other in either this equation of kinetic energy or this equation of momentum. Okay, and find out V1 as well as V2. Okay, so that's what we'll do. So because the equation of momentum is simpler one, we'll take that one. Okay, so we have this thing m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Okay, and from this equation I can find out, let's suppose v2. So this equation will imply that v2 is equal to what? u1 plus v1 minus u2. Okay, it is u1 plus v1. I take that u2 on other side minus u2. Okay, so u1 plus v1 minus u2. So we can substitute that here. Okay, and we also get v1 is equal to what? v2 plus u2 minus u1. Okay, so let's substitute this. v2 is equal to u1 plus what? u1 plus v1 minus u2. Let's substitute it here. Okay, so that means if we substitute for v2, we'll get an expression for v1. Okay, so we have m1 u1 plus m2 u2 equals to m1 v1 plus m2 multiplied by v2 is u1 plus v1 minus u2. So u1 plus v1 minus u2, and let's multiply out. So what do we get? m1 v1 plus m2 multiplied by this thing. So m2 u1 plus m2 v1 minus m2 u2. Okay, and then I will take terms containing v1 common. Okay, so it is m1 plus m2, right? If I take v1 common, it is m1 plus m2, and the other terms, which is m2 u1, I will take on left hand side, and minus m2 u2 also I will take it on left hand side. So what do I get? So m1, okay, so term containing u1, see it is m1 u1. If you take m2 u1 on left hand side, it is minus m2 u1. Okay, if you take u1 common, so it will be m1 minus m2, right? It will be m1 minus m2. So m1 minus m2 multiplied by u1 plus you have m2u2, and this minus m2u2 on left hand side becomes 2m2u2. So 2m2u2. Okay, and then you take m1 plus m2 also on left hand side, so you get v1. Okay, so v1 is equal to, if you divide by m1 plus m2, what do you get? m1 minus m2 divided by m1 plus m2 multiplied by u1, plus 2m2 divided by m1 plus m2 multiplied by u2. Okay, so we found v1, right? And this formula you have to memorize. Okay, and similarly we can find out v2 also. So what is v2? From this equation it is u1 plus v1 minus u2. Okay, so v2 is equal to u1 plus v1 minus u2. So I will substitute this v1 in terms of u1 and u2 here. So what do I get? I get u1 plus m1 minus m2 upon m1 plus m2 multiplied by u1. Okay, plus 2m2 divided by m1 plus m2 multiplied by u2 minus u2. Okay, so then you make denominator same, so it is m1 plus m2 multiplied by u1. Okay, so m1 plus m2 multiplied by u1, what will happen? So that plus m2 and minus m2 will get cancelled out and 2m1 will be left. Okay, 2m1 upon m1 plus m2 multiplied by u1, plus here what will happen? So if you multiply by m1 plus m2 here, okay, there will be minus m1 minus m2 because of this minus sign. So that one of the plus m2 and that minus m2 will get cancelled out. So what will remain there? So it will be m2 minus m1 divided by m1 plus m2. Okay, times u2. So this is v2. Okay, so this is v2. So you got these two relations. Which you have to memorize. In case there is direct question, okay, you can just substitute the values and you will get the answer. So is it clear? Then we'll see the special cases. Okay, so special case 1 is u2, sorry, not u2, first body is at rest. Okay, so special case 1 is first body is at rest. Okay, so u1 is equal to 0. So if you substitute u1 is equal to 0, that means this first body is at rest and second body is coming from backside, it gets collided with this body. Okay, then what will happen? You can substitute that. So the terms containing u1 will not remain there. So v1 will be equal to, you can directly say it is 2m2 upon m1 plus m2 times u2, and this m2 minus m1 upon m1 plus m2 times u2. Okay, so v1 is equal to 2m2 upon m1 plus m2 times u2, and v2 will be equal to what? m2 minus m1 divided by m1 plus m2 times u2. Okay, then see this here. Okay, if masses of two bodies are equal, what will happen? If masses of two bodies are equal, okay, so let's suppose in this one itself we'll consider that m1 is equal to m2 Okay, and suppose it's equal to m. So what will happen? So m2 is equal to m1 and it's equal to m. So this is 2m divided by 2m. Okay, so 2m upon 2m, that's 1. So see, 2m upon 2m is 1. So v1 equals to u2. Okay, v1 is equal to u2, and v2 will be equal to what? v2 will be equal to, so since m2 is equal to m1, so m minus m is 0. So v2 will be equal to 0. Okay, so this is a special case where masses are equal, and velocity of this first body is 0. u1 is equal to 0. Okay, so if u1 is equal to 0, then what will happen? Then suppose the second body comes with some velocity, it collides with this first body, and after collision, what happens? That first body, okay, it begins to move with the velocity of second body. Okay, it begins to move. So it begins to move with velocity u2, and this body, it comes to rest. Okay, so first body was at rest. Second one, let's suppose it comes with some velocity, comes with the velocity of 5 meters per second. So after collision, what happens? The body which is coming with velocity of 5 meters per second, it strikes with the first body, it comes to rest, and the first body begins to move with the velocity of 5 meters per second. Is it clear? Yes, no. Okay, so this thing we have to remember. And the second case is just case 2. We'll consider that m1 is equal to m2 is equal to m, but the first body is not at rest. Then what will happen? Okay, so if we substitute that in this equation, see, v1 is equal to this thing multiplied by u1. So if m1 is equal to m2, what will happen? This is 0. Okay, so 0 times u1. So this term will become 0. This is 2m divided by 2m multiplied by u2, because m1 is equal to m2 equals to m. So this is 2m, and m1 plus m2 is m plus m, that is 2m. So v1 becomes u2. Okay, and you can see this term will become 0 and v2 will become u1. Okay, so that means what happens is there is exchange of velocities. Okay, there is exchange of velocities. So v1 is equal to u2 and v2 is equal to u1. Okay, so what happens? If masses of two colliding bodies are equal, then there is exchange of velocities in case of the perfectly elastic collision. Okay, all right. So see, what did I say? So if masses of two bodies is equal, then there is exchange of velocities. Okay, then there is exchange of velocities, and this one, if you see, it is just special case of that first body was at rest, second body comes with some velocity and collides with first body. So second body which is coming with some velocity, it comes to rest, and first body begins to move with the velocity which is equal to initial velocity of second body. Okay, this is just special case of that, right? Okay, so let's see some questions. Okay, so this is long back from 1988, but there can be a question like this. The coefficient of restitution E for a perfectly elastic collision is how much? It's 1. Okay, right. Next question. A rubber ball is dropped from height 5 meter on a plane. On bouncing, it rises to 1.8 meters. The ball loses its velocity on bouncing by a factor of. This is simple, right? A ball is dropped from this height, which is 5 meters. Let's call it h1 or something, 5 meters. And after collision with the plane or ground, it rebounds and goes to this height, which is 1.8 meters. h2 is 1.8 meters. So can you tell me with what velocity it will strike and with what velocity it will rebound? I mean, can you tell me the formula for the velocity? If a ball is released from some height, with what velocity does it fall? That's the initial velocity. Okay? And the velocity with which it rebounds, it's suppose the final velocity. And you are asked, what is the loss? Okay? The ball loses its velocity on bouncing by the factor of. This is the question. So it will be 1 minus v2 by v1. Right? Alright, so let's first find out v2 and v1. So how much is v2? It will be square root of 2gh2 and v1 will be square root of 2gh1. A ball released from some height falls with how much velocity? Square root of 2gh. And a ball which moves upwards with some initial velocity, it will reach to some height. What's the relation between velocity and height? Again, v is equal to square root of 2gh. Okay, please remember this formula. I have told this several times, right? So please remember this. Okay, a ball released from a height, it falls with how much velocity? Square root of 2gh. Okay, so yeah, so this is simple now. So 2g and 2g gets cancelled. Okay, so it is 1.8 divided by root of 5. So can we do something here? Yeah, if we multiply by 5, what will happen? So this term becomes 25, this term becomes what? 5 times 1.8, 18 5s are 90. That means this will become 9. Right? So square root of 9 by 5, 9 by 25 is 3 by 5. So this is equal to 3 by 5. So is this the answer? What will be lost in velocity? What will be lost in velocity? So it will be v1 minus, okay, v2, right? v1 minus v2. This is loss in velocity. And you want the factor of that. By what factor? To the initial velocity. Okay? Does it lose the velocity? This is the question, right? So this is the thing that you have to find out. How much will be this? It will be 2 by 5. Right? Or take v1 common if you like. Okay, take v1 common. So what I mean, divide by v1. So this will be 1. 1 minus v2 upon v1. Right? So v2 upon v1, you have found out it is 3 by 5. So you want how much is the loss, not how much is final velocity with respect to the initial velocity. How much is the loss? Loss is 1 minus that fraction. Okay, 1 minus 3 by 5, that is 2 by 5 is the answer. So a body of mass 4m moving with speed u collides with another body b of mass 2m at rest. Okay, so first body is moving, its mass is 4m, this is first body, and its speed is u. Okay, so this is the initial momentum, right? So according to law of conservation of momentum, we can write 4m times u is equal to what? 4m times, this is mass of first body multiplied by its velocity v1 plus 2m multiplied by v2. Mass of second body is 2m, right? So it was at rest initially. Okay, so how much is total momentum before collision? It is momentum of first body only. Okay, 4m times u. Mass is 4m, velocity is u. Okay, what is total momentum after collision? 4m times velocity of first body plus 2m times velocity of second body, right? After that, so this is one equation that we can write. After that, what can we write? So since this is elastic collision, the total kinetic energy is also conserved, right? So I can say half of kinetic energy of first body 4m multiplied by u square plus kinetic energy of second body is 0 because it is at rest initially. This is equal to half of 4m multiplied by v1 square plus half of 2m multiplied by v2 square. Okay, so this is your equation number 2. Okay, I'm sorry. We can simplify these equations, right? So first of all, let's get rid of the 0. So then what can we do here? So this m gets cancelled. Then we can divide this equation by 2. So 2 times u is equal to 2 times v1 plus v2. So instead of this one, let's call this one the first equation. Okay, and then we can substitute for v2 here. So what will be v2? So from this first equation, what do you get? v2 is equal to 2v1 minus, sorry, 2u minus 2v1, 2u minus 2 times v1, or 2 times v minus u1. This is what you get, 2 times v minus 2 times u minus v1. This is what you get. Okay, so let's substitute that here. Okay, so then I can move this on left hand side. So what do I get? So before that also we can get rid of 4m, m, and half, or we can multiply by half. So if we multiply by half, what do we get? We get 2u square is equal to 2v1 square, okay, plus v2 square, right? So now instead of substituting this v2 square like this, what we'll do, we'll move this 2v1 square on left hand side. Okay, so we'll use the same trick that we had used in deriving the equations, in deriving the expressions for v1 and v2. Okay, if we don't do that, what will happen? We'll have to square, right? So we'll avoid that. So 2 times u square minus v1 square is equal to v2 square. Okay, so v2 is what? 2 times u minus v1 square. So we have 2 times u square minus v1 square, and it is equal to 2 times u minus v1 square of this. This will be 4 times u minus v1 square. Okay, and this can be written as what? 2 times u minus v1 multiplied by u plus v1. Okay, and this thing can be written as u minus v1 whole square can be written as u minus v1 multiplied by u minus v1. So this one u minus v1 gets cancelled out. Okay, and then we can divide by 2 also. So u plus v1 is equal to 2 times u minus 2 times v1. This is what we get. So we get what? Okay, yeah, and then we get 3v1, right, equals to u. 3v1 equals to u. This is what we get, or v1 is equal to, so that means v1 is equal to u by 3. Okay, clear till this point? Yes, no? Okay, so we found the final velocity of first body. Its initial velocity was u, final velocity is u by 3, and we want to find out what? The loss in kinetic energy. After the collision, the fraction of energy lost by body A is. So what will be fraction of energy lost? So final kinetic energy will be, sorry, again I am sorry. So fraction of energy lost will be 1 minus final kinetic energy divided by initial kinetic energy, right? So it is equal to 1 minus final kinetic energy is how much? Half of m into v1 square divided by initial kinetic energy is half of m into u square. So this half m gets cancelled. You have v1 divided by u square. So how much is v1 upon u square? So v1 upon u is 1 by 3. Square of that will be 1 by 9. Right? Square of that will be 1 by 9. And what is 1 minus 1 by 9? It is 8 by 9. So this is the answer. Okay, option C. This is the answer. So let's see next question. A moving block having mass m collides with another stationary block having mass 4m. The lighter block comes to rest after collision. When the initial velocity of lighter block is v, then the value of coefficient of restitution will be. This is the question. Okay, so there is a moving block of mass m. It collides with a stationary block whose mass is 4m. Okay, and this one comes to rest. So its initial velocity is v. It comes to rest, and we are asked what is the coefficient of restitution. Okay, so see, we can always use which law? Law of conservation of momentum, right? Okay, we can always use law of conservation of momentum. Okay, so whatever is the collision, elastic, inelastic, we can use law of conservation of momentum. So how much is initial momentum? M times v, because second body is at rest. Okay, how much would be final momentum? So after collision, first body comes to rest. Okay, so first body m comes to rest and second one begins to move with some velocity. So it is 4m times v2, we can say, right? It begins to move with velocity v2. That we don't know, but we can find out. Okay, so this m and m will get cancelled out, and then we can take 4 on the other side. So v2 will be equal to what? V2 will be equal to v upon 4. Okay, v2 is v upon 4. And now what is coefficient of restitution? So it is, you can say, v2 minus v1 upon u1 minus u2, or vice versa, right? Vice versa meaning, if you write in numerator v1 minus v2, so in denominator you will write u2 minus u1. Okay, so how much is v2? So v2 is v by 4. If v2 is equal to v by 4, that means velocity of second body is v by 4, right? So it is v by 4 minus 0, velocity of first body is 0. It was u1. Okay, u1 is equal to v. Okay, so v minus u2 is equal to 0. Velocity of second body is 0. Okay, so now v and v gets cancelled. So it is v by 4 upon v, that v and v gets cancelled, 1 by 4, so that means 0.25. This is the answer. Yeah, so option B. Let's see next question. So 1991, 1994, 2016, and there was one more time. Okay, so before I cropped these questions, there was one more time. So this kind of, or this question itself. Okay, so this question without changing values, they have repeated 4 times. Okay, So there must be something in this question. I don't know. Alright. So two identical balls A and B having velocities of 0.5 meters per second and 0.3 meters per second respectively collide elastically in one dimension. The velocities of B and A after the collision respectively will be. They collide elastically. Okay, two identical balls. That means their masses are equal. So tell me what's the answer? What will happen? What happens when two masses, two equal masses collide elastically? Their velocities yeah, exchanged. Okay, their velocities get exchanged. That means velocity of first one, initial velocity of first one will be final velocity of second one, and initial velocity of second one will be final velocity of first one. So tell me, velocities of B and A. So velocity of B will be initial velocity of A, right, 0.5, and velocity of A will be the initial velocity of B. So 0.5 and 0. Minus 0.3 is the answer. So option B, right? We just have to remember, okay, then it's very simple. We just have to remember that when two identical masses collide elastically, then their velocities get exchanged. Then it is very simple. Okay, otherwise if you use the formula and solve, okay, it will take a lot of time. All right, let's see next question. Two particles A and B move with constant velocities v1 bar and v2 bar. At the initial moment, their position vectors are r1 bar and r2 bar respectively. The condition for particles A and B for their collision is. Okay, so this is the question. Sorry. So there are two particles. Their position vectors are r1 bar and r2 bar. Velocities are also given. Okay, at time t equals to 0. So after time t, if the particles collide, what can you say about their position vector? At time of collision, what can you say about the position vector? Okay, if they collide at the time of collision of two particles, their position vector will be equal, right? So position vector, I can say r1 final bar is equal to r2 bar final, right? So how can you write this r1 final and r2 final? So it is r1 bar, the initial position, plus velocity multiplied by time, right? And r2 final is initial r2 plus, that means initial position, plus velocity multiplied by time. Okay, so then move this on left, move this on right. Why? Because options are telling you to do so. Okay, so then if I move this towards left, move this towards right, what do I get? I get r1 bar minus r2 bar is equal to, okay, because there are some options like this, v1, oh, I wrote v1 v1 only, this is v2, so it is v2 bar minus v1 bar multiplied by t. Okay, so t is a number. What can you say about these two vectors, r1 bar minus r2 bar and v2 bar minus v2 bar, v1 bar, sorry, r1 bar minus r2 bar is equal to some number multiplied by v2 bar minus v1 bar. So what can you say about this vector and this vector? Let's suppose these are two vectors and these two are parallel to each other. Okay, these two are parallel to each other. Then only I can write that this vector, okay, whatever it is, okay, this vector is equal to some number multiplied by this vector. If they are parallel only, if they are parallel, then only I can write like that. Yes, no? Okay, so here I can say this vector, let's call it A, and this is B. So A bar is equal to 2.5 times B bar. So that means the two vectors are parallel. Okay, so which of these options is correct? Can you tell me? If you take t equals to 1 second, okay, option B is also correct, right? If you take t equals to 1 second, if you take t equals to 1, this option is also correct. Okay, so maybe the question designers, they haven't thought about this point. All right, for t equals to 1 second, this is also correct. But which of these options is always correct? So if two vectors are parallel, then the unit vector of this will be equal to unit vector of this, right? And how do you find unit vectors? So see this. Okay, a vector divided by its magnitude will give you a unit vector, right? A vector divided by its magnitude will give you unit vector. So see, this vector divided by its magnitude, you can see this option C. Okay, this is the answer, right? So r1 bar minus r2 bar divided by its magnitude will give you unit vector in direction of this vector, magnitude of r1 bar minus r2 bar. This is a unit vector. So it will be equal to unit vector of v2 bar minus v1 bar divided by magnitude of v2 bar minus v1 bar. Okay, let's see the next question. A ball is thrown vertically downwards from a height of 20 meters with an initial velocity v0. It collides with the ground, loses 50% of its energy in collision and rebounds to the same height. Okay, the initial velocity v0 is. This is the question. All right. So it is thrown with some velocity, right? So what can we say? From what height? 20 meters. So initial velocity is v0. It is thrown from height 20 meters. Okay. So the velocity with which it strikes the ground, how much will be that? So this is u is equal to v0 and final velocity is suppose v. Okay, so v square is equal to u0 square plus 2g h. This thing we can write. Okay, and again what is given? That it rebounds to the same height. It rebounds to same height h. But now its kinetic energy, 50% of its energy is lost. Okay, 50% of kinetic energy is lost. So if 50% of kinetic energy is lost, that means you can say what? Okay, so the speed with which it rebounds, v dash, will be equal to what? V by 4. Sorry, v by root 2. Okay, see, half of m into v dash square. Okay, what is v dash? The speed with which it rebounds. Okay, it collides with speed v. The speed with which it rebounds is v dash. So half of m into v dash square is equal to half of m into v square, because 50% of energy is lost. This is clear. Okay, Preeti? The speed with which it rebounds, all right, is equal to what? So kinetic energy with which it rebounds is half of the kinetic energy with which it strikes. Okay, because 50% energy is lost. Okay, so mm and this half can get cancelled. Okay, so you get v dash square is half of v square. Okay, so v dash square, which is half of v square, is equal to, can you say 2gh? Because they are saying it goes to the same height. Okay, it rebounds with half of the kinetic energy, but it goes, okay, it rebounds to the same height. That means v dash square will be equal to 2gh. So half of v dash square is 2gh. Okay, so what is v square? Half of v square is 2gh. So v square will be equal to 4gh, right? And you can substitute that here. You can substitute this here. So what do you get? You get 4gh is equal to u naught square plus 2gh. Okay, it was v naught, right? Not u naught. Sorry, it was v naught. Whatever. Okay, we want to find out that speed only. So take this 2gh on left hand side. V naught square is equal to 2gh. V naught square is 2gh. That means v naught is square root of 2gh. Okay, so what is 2gh? That is square root of 2 multiplied by 10 multiplied by how much was the height? 20. So square root of 20 square, that is 20. 20 meters per second is the answer. Okay. Alright. On a frictionless surface, a block of mass m moving at a speed v collides elastically with another block of same mass. Okay, collides elastically, which is initially at rest. After collision, the first block moves at an angle of theta to its initial direction and has a speed v by 3. The second block's speed after the collision is. This is simple, right? See, there are two blocks, okay, two masses. Okay, never mind. This is masses. These two bodies have same masses. Okay, so they collide. The second one, it collides elastically with another block which was initially at rest. So this one was initially at rest. Okay, and then they collide. What happens after the collision? This one goes in some direction, theta. Okay, so this one which was at rest, it goes in some direction, theta. Okay, the second block speed, okay, second block speed is asked. So this m will go in some other direction. Its speed is asked. So what was the initial speed? V. What is speed of this block? V by 3. What will be speed of this one? This is the question. So what can we say about elastic collision? Total kinetic energy is conserved, right? Total momentum is conserved. But if you think about momentum, you have to resolve, okay, you have to resolve this momentum along two components, okay, momentum of this body also along two components, and then solve this. And theta is also not given, right? So total kinetic energy is conserved. So you have speed of first object, okay, the speed of second object after the collision, and you want to find out speed of this first object after the collision. Okay, so straightforward, the total kinetic energy is conserved because this is elastic collision. So what can you say? Half of m into v square is equal to half of m into v1 square, and v1 is v by 3. Okay, v by 3 square plus half of m multiplied by v2 square, right? Okay, can we say this, Sanjay? Okay, so then half m, half m, half m gets cancelled out, right? Then v by 3 square is v square by 9. Move it towards left. So v square minus v square by 9 will be how much? That is v2 square. So v2 square is v square minus v square by 9. So it is 8 by 9, right? 8 by 9 v square. This is v2 square. So v2 will be how much? Square root of 8 by 9 v. Okay, so v2 is how much? So v2 equals to square root of 8 by square root of 9. Square root of 9 is 3 times v. This is the answer. Okay, yeah, 2 root 2. Option C is the answer, because 8 can be written as 4 times 2, and square root of 4 is 2. 2 times root 2 divided by 3. This is the answer. Got it? Yes, no?